Good morning, friends. Welcome to Engineering Works 247. Today we are going to discuss about the IS code 1893-2025, which is related to seismic design. The first it was of ISO 1893-2016, then it is revised to 2025. Then in this video we will learn about the key changes that were transformed from ISO 1893-2016 to 2025. The first change is the zones. Previously there were four zones on which the Indian map was divided. You can see here zone 2, zone 3, zone 4 and zone 5. And as per revised Indian Standard Code, there are five zones. Zone 2, Zone 3, Zone 4, Zone 5 and Zone 6. You can see the new change the map as per the zoning in the IS code 1893-2025. Here, as we can see in 2016, there were four zones, and in 2025, Zone 6 is newly added in the Indian map. Zone values linked with return period of the earthquake. We can see here the zone values are linked with the return period of the earthquake. And in previous 2016, there were no linked values of the earthquake. So in 2025, there are return period is classified into special, critical, important, and normal. These are the building types in which the return period is find out. For calculation of design horizontal seismic coefficient, previously there was formula was Z by 2 into SA by G upon R upon I. Now the formula is revised and much complicated. You can see here VBDH for so that design base shear in horizontal direction can be calculated as Z into I into ANH TH upon R into W. This is the formula for horizontal direction, and for the base shear for the vertical direction we can see here VBDV is equal to Z into I into AN with TV into W. For design base shear in vertical direction, the R, which is response reduction factor, is completely ignored, so that the in horizontal direction R is considered and in vertical direction the R is not considered. Then for design spectra, which is for equivalent static analysis, in 2016 there was up to natural period 6 seconds only, and as per new IS code which of 2025, the natural period is increased up to 10 seconds. Before it was up to 6 seconds, and as per new conditions it is increased up to 10 seconds. Same is for response spectrum method. Before there was the natural period was for 6 seconds, and in 2025 it is increased up to 10 seconds. And we will learn the what's changed in IS 1893-2025. The first thing is refined interpretation of seismic demands. So the new code explains that earthquake forces more clearly. It also gives better guidance on how much of force building should be designed, so that the designer should not underestimate or overestimate the seismic loads. Second one is the stronger control on tall and irregular buildings. So tall and irregular buildings with irregular mass or stiffness are now checked more strictly. The code limits oversimplified methods and require proper analysis to ensure the safety during the earthquake. The third is the rationalized use of response reduction factor. The use of response reduction factor is now more logical. Designers must justify the value of R based on the structural system, ductile detailing, and actual behavior, instead of blindly assuming the higher values of the response reduction factor. The next one is the clearer intent for the importance factor. The code clearly explains when and why higher importance factor to be used. Buildings like hospital, emergency center, and essential services must be designed for the higher safety levels. And the next is for great emphasis is on dynamic analysis. Dynamic analysis is strongly encouraged, especially for tall, irregular, and important buildings. This helps capture real earthquake behavior more accurately than simple static method. And the last one is better alignment between design, detailing, and execution, so that the code ensures the structural design assumptions match actual construction and detailing practices, so that this reduces the gap between what is designed on paper and what is built on site. So that these were the changes in IS 1893 2016 to 2025. We will learn in detail the more about this in the next video. And finally, thank you.